I'm continuing my past paper session, and I was doing IGCSE, that is 0620. This time I've selected 42, paper 42. You know, it's paper 4, theory extended version, May, June 2025, and total time is 1 hour 15 minutes. Total mark for this paper is 80. You can use calculator in this paper. Periodic table is written in the question paper. So let's start with the question number 1 here. Here's question number 1. Using numbers only, state the A percentage of nitrogen in clean, dry air. Now you have marking key states, it's 78. You can even write 79, 78 or 79. The typical operating temperature of the contact process in centigrade. This is something you have to learn. 450 degrees centigrade. You know that this high temperature is needed in the contact process to increase the rate of reaction. Although the forward reaction is exothermic, it prefers low temperature, but this is a temperature compromise for contact process. See, number of metals in period 3 of the periodic table. So where's period 3? Here's period 3. It's period 1, period 2, period 3. These are the periods. So they are saying number of metals in period 3. So we have sodium, magnesium, and aluminum. Silicon is not a metal, it's included in metalloids. So we will write 3 here. Only 3 metals are there. D, number of halogens which are gases at RTP. So here's group 7. Group 7 also known as halogens. So we have only 2 gases in halogens. That's fluorine and chlorine. So I will write 2 here. E, typical temperature for the fermentation of aqueous glucose in centigrade. It's between 25 to 35 degrees centigrade. So you write 25 to 35. F, number of unbranched structural isomers of C4H8 which decolorizes aqueous bromine. Now, this one is alkene because it follows the general formula CnH2n. This is of alkene. Now, they are saying number of unbranched, not branched, unbranched structural isomers of this alkene. This is butene. C4H8 is butene. So if you draw the structure of butene, you have 2 different positions for the carbon-carbon double bond. First of all, I'm going to show the 4 carbon, 1, 2, 3, 4. Now it's up to you whether you will place double bond between carbon number 1 or 2. For example, I'm placing the double bond between carbon number 1 and 2 from right hand side. So we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. These all are hydrogen. I'm not showing hydrogen. This is but-1-E. This is carbon number 1, but-1E. The other isomer, unbranched isomer. In fact, they are saying unbranched, not the branch. So you are going to show this 1, 2, 3, 4. Now I'm going to place double bond on carbon number 2. So whether you start from the right hand side or left hand side, you have these 2 middle carbon atoms will be considered as 2 and 3. 1, 2, 3, 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So you have only 2 unbranched structural isomers of this alkene. This is but-2-ene. So I'm going to write 2 here. What about G? Number of covalent bonds in one molecule of ethanol. The molecular formula of ethanol is C2H5OH. So I'm going to show each covalent bond in a molecule of ethanol. So we have 2 carbon atom in ethanol, 1, 2, and we have 1 OH also. O forms single bond with carbon as well as 1 with hydrogen. What about the other hydrogen atoms? 1, 2, 3, 4, 5. So this will be C2H5OH. Now let's count the number of covalent bonds in this molecule. 1, 2, 3, 4, 5, 6, 7, 8. it's 8. There will be 8 covalent bonds here. H. Number of carbon atoms in one molecule of propyl butanoid. Now it's up to you whether you want to draw the structure of this propyl butanoid. Otherwise, I can do this by looking at this. Propyl means you will definitely have 3 carbon atoms. So you have 3 for propyl plus. What about butanoid? Butanoid means means 4 carbon. So 3 plus 4, you will get 7. 7 must be the final and right answer for this one.
Welcome to Chain of Qualified Tutors. Unlock your academic potential with expert tutoring, from secondary school to graduation level. Master math, science, English, and more with personalized one-on-one guidance. Call or WhatsApp for a free demo session. We offer on-site and online tuition.
Number 2. This question is about covalent compounds. A. State what is meant by a covalent bond. Now they are asking the definition of a covalent bond. So you have pairs of electrons shared between 2 atoms. Pair of electrons are shared between 2 atoms. Now, it's very important. These 2 must belong to non-metal group. This will be the definition. B. Chlorine 1 oxide Cl2O is a simple molecule with covalent bonds. 1. State what is meant by 1 in the name chlorine 1 oxide. This is Roman number. The number is written Roman and it represents the oxidation number. So I'm going to write oxidation number. Oxidation number, comma, +1. +1. Number 2, complete the dot and cross diagram in figure 2.1 of a molecule of chlorine 1 oxide. Show outer electrons only. Now, where's chlorine? Here's chlorine. Chlorine is in group 7, which means it's having 7 valence electrons. What about oxygen? Here's oxygen. It contains 6 valence electrons. 7 valence electrons for chlorine means it needs 1 electron to complete its valence shell. And 6 electrons for oxygen, it means that it needs 2 electrons to complete its valence shell. So oxygen atom will share 1 electron each with these chlorine atoms. So let's show the key on the right hand side. I'm using cross for chlorine, and for oxygen, I'm using dot. So for chlorine, we have 1, 2, 3, 4, 5, 6, 7. For the left hand side, we have 1, 2, 3, 4, 5, 6, 7. What about oxygen? It's having 6 valence electrons. So we have 1, 2, 3, 4, 5, 6. This will be the final dot and cross diagram in this case. 3. Explain in terms of structure and bonding why Cl2O boils at a low temperature and does not thermally decompose into its constituent elements Cl2 and O2. So they are saying you have to explain this in terms of structure and bonding. So we have to consider structure and bonding. Structure is a simple molecule and bonding is covalent bonds. So covalent molecules, when we say covalent molecules, they will be having weak attraction between molecules. So what's happening during boiling? The force of attraction between molecules are broken. So we'll start with the boiling at low temperature. So we'll write during boiling. Force of attraction between molecules are broken. What will happen during thermal decomposition? They are also asking why does not thermally decompose. So what you're doing during thermal decomposition, we are getting constituent elements, that is Cl2 and O2. So it means you are breaking the covalent bonds. Covalent bonds. So the bond is strong. So during thermal decomposition, covalent bonds are broken. Covalent bonds are broken. So later what you are going to write in molecule, there will be weak attraction, but the covalent bonds are strong. Weak attraction between molecules and strong covalent bonding. Strong covalent bonding. That's why it does not thermally decompose into its constituent elements due to this strong covalent bonding. 4. Give 2 reasons why liquid Cl2O is a poor conductor of electricity. So it's a liquid, which means it does not contain any ions. Does not contain mobile ions. Does not contain mobile ions. What else you can write? It also does not contain mobile electrons or delocalized electrons. Mobile or delocalized electrons. That's why it's a poor conductor of electricity. Part C. Carbon and silicon 4 oxide both exist as giant covalent structures. 1. Name a giant covalent structure of carbon which conducts electricity. It's graphite. Contains mobile electrons. That's why it's a good conductor of electricity. Number 2, identify the particles responsible for the conduction of electricity in this covalent structure of carbon. Definitely mobile electrons, I've just mentioned. Number 3, silicon 4 oxide contains silicon atoms, Si and oxygen atoms. O. Figure 2.2 shows part of the giant covalent structure of silicon 4 oxide. Complete the diagram in figure 2.2 by adding the symbol for each of the 9 atoms shown. So how you're going to draw? I'm going to place silicon between oxygen atoms. You must be having silicon here. We have SiO2 and it's attached with oxygen atoms. We'll be having oxygen here, 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 and it's again attached to silicon. So here we are having oxygen again here, and silicon again, and here also silicon, and here you will have silicon. This will be the final structure for this one. Number 3, this question is about electrolysis. A. Complete the definition of electrolysis by filling in the missing words. The decomposition of ionic compounds. Remember, in electrolysis, we are decomposing ionic compounds. So you write ionic air. When dash or dash by the passage of an electric current. When it's in the molten state or aqueous. So you write molten. And here you're going to write aqueous. B. Electrolysis of aqueous copper 2 sulfate is carried out using the apparatus shown in figure 3.1. The electrodes are made of platinum. Remember, platinum is inert. It's inert electrode. Inert electrode is the one which provides mobile electrons and does not participate in the electrolysis except providing these mobile electrons. Number 1, state whether the mass of the cathode increases, decreases, or remains the same when platinum electrodes are used? It definitely remains. So you are having copper 2 sulfate, sorry, copper 2 sulfate, one of the cathode, mass of the cathode, you will have copper 2 plus ion. It will move to the cathode. So it will increase in mass because copper will deposit at the cathode. So you write increase. Number 2, describe the change in appearance, if any, of the electrolyte when platinum electrodes are used. Definitely the blue color, copper 2 sulfate is blue in color. Here's copper 2 sulfate, it's blue in color. You know that copper 2 plus ion, it's blue in color. It becomes blue to colorless. So you write blue to colorless as electrolysis progresses. Describe what is seen at the anode when platinum electrodes are used. So at the anode, what you will get? You will get oxygen and water. Oxygen and water. So you'll see bubbles of oxygen. This is what we'll observe at anode. For write the ionic half equation for the reaction at the anode. So you have OH negative ion. It will lose electron, produce oxygen gas, water molecule. Let's balance the equation. We'll have 4 moles of OH negative ion, 1 mole of O2, 2 moles of H2O, and 4 moles of electron. This equation is balanced. C. The electrolysis is repeated using copper electrodes. State whether the mass of the cathode increases, decreases, or remains the same when copper electrodes are used. Now, if you use the copper electrodes, again, the mass of the cathode, it will increases because copper will deposit at cathode. So you will write increases. Number 2, describe the change in appearance, if any, of the electrolyte when copper electrodes are used. So when copper electrodes are used, the cathode will gain in mass due to deposition of copper, and copper anode will dissolve to compensate the loss of Cu2 plus ion in the solution. So the change, you'll write no change or remain same. Remain same or no change. Aluminium is extracted from its purified ore by electrolysis. Name this ore of aluminium. It's bauxite. Number 2, name the substance added to this process to reduce the operating temperature. Now, in order to reduce the operating temperature, you need to add the compound of aluminium here, and it's cryolite. We are adding cryolite in this to reduce the temperature, cryolite. So you write cryolite. Number 3, explain why the anodes need to be continually replaced during this process. Now the carbon anode, it oxidizes or reacts with oxygen to form carbon dioxide. Carbon anode oxidizes or react with oxygen to produce carbon dioxide. Question number 4. Chromium is the element with atomic number 24 in the periodic table. The main ore of chromium is chromite. Chromite contains FeCr2O4. FeCr2O4 reacts with carbon. Complete the equation for this reaction. Here's the reaction. You see, iron is produced and chromium is also separated. both iron and chromium separated. So what is left? We have carbon and oxygen. So both of these, this will react and it forms carbon monoxide. 4 moles of carbon monoxide. If you look at this, you will get 4 moles of carbon monoxide, CO. 1. Suggest one disadvantage of extracting chromium by reacting chromite with carbon. One disadvantage is that we are also getting iron beside chromium. So chromium will need to be separated from iron. Chromium will need to be separated from iron. B. Chromium can be mixed with nickel and other elements to form stainless steel. Name the type of substance formed when a metal is mixed with other elements. It's known as alloys. C. NH4 whole twice Cr2O7 is a compound containing chromium. The negative ion in NH4 whole twice Cr2O7 is Cr2O7 2 minus. State the sum of the oxidation numbers in the Cr2O7 2 minus ion. So if you look at the chart, it's already mentioned, it must be having 2 minus as a sum of the oxidation numbers. So I will write 2 minus. 2. The oxidation number of each O in Cr2O7 2 minus ions is minus 2. Determine the oxidation number of each Cr in Cr2O7 2 minus ions. Show your working. So I'm going to consider X as for Cr. So we have 2 Cr here. So I will write 2 Cr plus we have 7 atoms of oxygen. So 7 will be multiplied by the oxidation number of oxygen, which is minus 2 here. The overall charge it's given, it's 2 minus. So I'm going to write 2 minus here or minus 2. So 2x minus 14 is equal to minus 2 or 2x is equal to minus 2 plus 14. Then x becomes equal to plus 12 divided by 2. This will give plus 6. So plus 6 will be the oxidation number of each Cr in Cr2O7 2 minus ions. Number 3. When NH4 whole twice Cr2O7 is heated, the following reaction occurs. So what we are getting? We are getting Cr2O3 plus 4 moles of H2O plus 1 mole of N2. Calculate the volume of nitrogen gas produced at RTP in centimeter cube when 1.26 gram of NH4 whole twice Cr2O7 is heated using the following steps. The MR of NH4 whole twice Cr2O7 is 252. Calculate the number of moles of NH4 whole twice Cr2O7 used. So in order to find the number of moles, we need to divide the mass of NH4 whole twice Cr2O7 by its MR. So 1.26 divided by 252. So what you will get? 1.26 divided by 252. 0.005. 0.005. Determine the number of moles of N2 formed. So if you look at the relationship is 1 mole gives 1 mole. Therefore, 0.005 mole gives 0.005 moles. So I'm going to write 0.005 moles. Calculate the volume of N2 formed at RTP in centimeter cube. So we know that 1 mole, it contains 24,000 centimeter cube at RTP. 1 mole contains 24,000 centimeter cube. Therefore, 0.005 moles contains X centimeter cube. So this will be multiplied like this. What do we get? X is equal to 0.005 multiplied by 24,000. 120. So 120 centimeter cube will be the final answer for this one. Moving to next question. Number 5. Alkali metals are reactive metals. A. State the group number of the alkali metals. So here we are having alkali metals. That's group number 1. They are alkali metals in the periodic table. So you are going to write group 1. Identify the alkali metal which has the highest melting point. Now the trend for the melting point in this group is that the melting point decreases as you go down the group, which means the first element must be having the highest melting point. So answer will be Li or lithium. Number 2, has the highest density. For density, the trend is density increases as you go down the group. So francium will be the one which has highest density. So Fr or francium will be the answer for this question. Number 3, has the lowest reactivity. Reactivity increases down the group. So lithium will be the one which will be least reactive or lowest reactive in this. So Li or lithium. Number 4, burns with a lilac flame. This is something which you have to learn. You write K or potassium. It burns with lilac flame. Number 5, is found in fertilizers to improve plant growth. Against potassium. Potassium is used in fertilizer to improve plant growth. So you write K or potassium. C, sodium sulfide Na2S is an ionic compound. Complete figure 5.1 to show the electronic configurations of the ions in sodium sulfide. Show the charges on the ions. So sodium is in group 1 here, and it has 1 valence electron. So it will lose its 1 valence electron to form Na plus ion. So I'm going to put charges first for both of these Na plus. What about the electrons? Look at the proton number. The proton number is 11, which means now it will be left with 10 electrons. Na contains 10 electrons now. So 2 electrons are already shown. So in the second shell, we need to show 8 more electrons. 1, 2, 3, 4, 5, 6, 7, 8. For this one, 1, 2, 3, 4, 5, 6, 7, 8. Both of these have lost their 1 valence electrons. What about sulfur? Sulfur is in group 6. Here's group 6. And the proton number of sulfur is 16. And it has gained 2 electrons. And it's gaining 1 electron from each sodium. So now it has 18 electrons. They have already shown the 10 electrons. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need to show 8 more electrons. Remember, 2 electrons are coming from sodium atoms. So we need to show through dot, using dot. So first of all, I'm going to show the electrons coming from sodium. This one from one sodium and this one from another sodium. Now we need to show the valence electrons of this sulfide ion. 1, 2, 3, 4, 5, 6. Now it has gained 2 electrons. So you will put -2 or 2 minus. D. Rubidium has only 2 naturally occurring atoms. RB85 and RB87. State the term given to these naturally occurring atoms of rubidium. They are known as isotopes. Part 2. Complete table 5.1 to show the number of protons, and neutrons, and electrons in the atom and ion of rubidium shown. So let's look at the proton number of this rubidium. So rubidium, where is rubidium? It's in group 1. 37 is the proton number. So it means RB85, it has 37 proton. What about electron? Electron will be 37. The one neutron, you need to subtract 37 from 85. 85 minus 37. 85 minus 37. 48. 48 will be the number of neutrons for RB85. What about RB plus? RB87 plus. It's carrying plus charge. RB87, it's carrying plus charge, which means it has lost one electron. So proton will remain same, that is 37. For electron, I need to subtract 1 from this 37 minus 1. This will become 36. What about the number of neutrons? Simply subtract this 87 from 37 from 87 this time. So 87 minus 37. What you will get? 50. 50 will be number of neutrons out of this ion. The relative atomic mass of rubidium to one decimal place is 85.5. Determine the relative abundance of RB85 in rubidium. Express your answer as a percentage. Now they are asking relative abundance of RB85. We have two isotopes. These are the isotopes. So if I will consider RB85 as X, RB85 as X, then RB87 will be considered as 100 minus X. Now, so equation will be like this: 85X divided by 100, and for the second one we have 87 multiplied by 100 minus X divided by 100 is equal to the atomic mass, relative atomic mass given 85.5. Further solving we will get 100. We have 85X plus 87 multiplied by 100. What you will get? You will get 8700 minus 87X is equal to 85.x. So we will get minus 2x plus 87, 8700 is equal to 85.5 multiplied by 100. This will become minus 2x plus 8700 is equal to 8550. Fine. So now minus 2x is equal to 8550 minus 8700, which will become minus 2x is equal to minus 150, or x is equal to 75. So 75 will be the percentage for this RB85. Ethene. C2H4 is the first member of a family of similar compounds which contains the alkene functional group. A, state the term for a family of similar compounds which contain the same functional group. Homologous series. D. Determine the difference in relative molecular mass between C2H4 and the next member in this family of similar compounds. Each member differs by 14 units. So you write 14 here. C. Write the symbol equation for the complete combustion of C2H4. So you know that complete combustion, there will be reaction between alkene, that is ethene, and oxygen. The product will be carbon dioxide and steam or water. Balance this equation. So we'll put 2 before CO2. Carbon is balanced. What about hydrogen? 2 before H2O. Hydrogen and carbon both are balanced. What about oxygen? 2 to the 4. 4 plus 2, 6. So I will place 3 before oxygen. Now this whole equation is balanced. D. C2H4 reacts with steam to form ethanol. C2H4 gas plus H2O gas, reversible sign. C2H5OH gas. Delta H is minus, which means it's exothermic. The forward reaction is exothermic. The process happens in a closed system and the reaction reaches an equilibrium. The conditions for this process are 300 degrees centigrade and 60 atm pressure. H3PO4 is used as a catalyst. One complete table 6.1 to show the effect, if any, on the concentration of C2H4G when the following changes to the conditions are applied. Only use the words increases, decreases, or no change. So, what will happen on the effect on the concentration of C2H4 at equilibrium if temperature is decreased? If you decrease the temperature, the equilibrium will shift to the right hand side because the forward reaction is exothermic. So this will definitely decrease the concentration of C2H4. So I'm going to write decreases. Some C2H5OH is removed. So we are removing C2H5OH. So what will happen? The equilibrium will shift to the right hand side. Again, it means the concentration of C2H4 will decrease. So decreases. Pressure is increased. If you increase the pressure, what will happen? The equilibrium will shift to the side where there will be less number of moles. So if you look at the moles of volume of gases, we have 1 plus 1 is equal to 2, reversible sign 1. So if you increase the pressure, it will shift the equilibrium to the right hand side, which means again the concentration of the C2H4 will decrease. So you'll write decreases again. A more effective catalyst is used. Catalyst only increases the rate of reaction. It has no effect on the concentration of either reactant or product at equilibrium. So you write no change. To explain in terms of collision theory why the rate of the forward reaction increases if the temperature increases. Now it's a 3-mark question. So they have already mentioned that the rate of the forward reaction increases. So first of all, what you are going to do? You can refer to the movement of particles or energy. Refer to the movement or energy of the particles. Like you can write particles have more energy or particles move faster. Then you have to refer to the proportion or percentage or ratio of particles having energy equal to or higher than EA. Then refer to the proportion, percentage, or ratio of particles having energy equal to or higher than EA, which means in this case, what you're going to write? You will write higher proportion or higher ratio of particles have energy equal to or higher than EA. Last but not least, frequency of collision. Refer to the frequency of collision. We have more successful collision or frequency of collision increases. Frequency of the collision increases, or more successful collision. So in this way, you are going to gain 3 marks for this question. Part E. Compound B has the displayed formula shown in figure 6.1. Reduce the molecular formula of compound B. So we are having C here, carbon, hydrogen and oxygen. Let's count carbon. 1, 2, 3, 4, 5. So C is 5. What about hydrogen? 1, 2, 3, 4, 5, 6. 6. What about oxygen? 1, 2, 3, 4. So formula must be C5H6O4. State why compound B is unsaturated. You see the double bond is there. That's why. Sorry. You have the double bond. So what you're going to write? Contain carbon-carbon double bond. Contain carbon-carbon double bond. What else you can write? Or not all carbon-carbon bonds are single. Or not all carbon-carbon bonds are single. Three, draw the structure of one repeat unit of the polymer found when compound B undergoes addition polymerization. If you look at this, due to the presence of this carbon-carbon double bond, it will undergo addition polymerization. So what I'm going to do, I'm going to show this group as CH3, bond CH3. For this one, COOH or CO2H, bond, again this one, bond CO2H. The rest will structure will remain same. So we have CO2H here and CH3 here on the right hand side, and CO2H here we are having hydrogen. So this must be the repeat unit for this one. So this will be the one repeat unit for the addition polymer. Explain why 1 mole of compound B reacts with 2 moles of sodium hydroxide NaOH. Now if you look at the structure, it contains carboxyl group, 2 carboxyl group. These carboxyl groups are acidic group. So these 2 hydrogen will be replaced by sodium. On reaction with this sodium hydroxide, these will be replaced by sodium and water molecule will be formed. So it needs 2 moles of Na. That's why it needs 2 moles of sodium hydroxide. Sodium hydroxide is alkali to react with this carboxylic acid. So we will write presence of 2 carboxylic acid groups. presence of two carboxylic acid groups. 5. Calculate the volume in centimeter cube of 0.25 mole per dm cube. Anyway, that reacts with 0.1 mole of compound B. So first of all, I'm going to find the mole ratio. So if you look at the equation, compound B, we have 1 mole of compound B. Compound B, 1 mole reacting with 2 moles of NaOH. Therefore, they are saying 0.1 mole, 0.1 mole react with X mole. So X is equal to 0.1 multiplied by 2 or 0.2 moles. So 0.2 moles. So looking at this information for NaOH, 1000 contains 0.25 moles or X 1000 centimeter cube, or X centimeter cube is in 0.2 moles. So do the cross, you'll get X is equal to 0.2 multiplied by 1000 divided by 0.25. 0.2 multiplied by 1000 divided by 0.25. 800 centimeter cube. This will be the final answer. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.